Hello students, welcome to our YouTube channel Experience Tutor. Today we will discuss class 10th science chapter 3 metals and nonmetals part 3. And here is our welcome message. We request you to subscribe, like and share our channel. Please click on the subscribe button to support us and also click on the bell icon so that you can get automatic notification whenever a new video is uploaded. Now let us begin with the lesson. In the last class we have studied about the uh, amphoteric oxides and their reactions. In today's class we'll study about reaction of metals with water. So reaction now metal reacts with water metal plus water gives metal oxide plus hydrogen. And metal oxide reacts with water to give metal hydroxide. Now, if we let us draw the brain diagram for the reactions of metals with water. So, metals so reacts with cold water Na, K and calcium, sodium, potassium and calcium. Now reacts with steam Al, F, Fe and Zn. Iron, aluminum, iron and zinc. Reacts with hot water, magnesium. Calcium and and magnesium floats as bubbles of float as bubbles of H2 stick to their surface. And no reaction no reaction with H2 with H2O with water, Pb, Cu, Au and Ag. So this is the brain diagram for which you can get a synopsis, just a snapshot that how and what are the conditions metals reacts with water. Some metals reacts with cold water, some metal reacts with hot water in this way. Now let us see few reactions. How metals reacts with water. So examples: to Na plus 2H2O gives 2NaOH plus H2 plus heat. So in the last session, what we have learned that whenever metal reacts with water, it gives metal oxide and hydrogen. So in this case, and whenever metal oxide reacts with water, it gives metal hydroxide. So in this case, we are getting metal sodium. Whenever sodium reacts with water, it gives sodium hydroxide and hydrogen gas is evolved. In the same way, in the same way, so sodium, magnesium, potassium, calcium, these all are of similar type of reaction, give similar type of product after reacting with water. So say calcium reacts with water to give calcium hydroxide, and H2 gas is evolved. Similarly, magnesium reacts with water to give magnesium hydroxide plus hydrogen gas. So these are different type of reaction which gives metal hydroxides. Now we'll see a different type of reaction where we'll get metal oxide. So the reaction of aluminum and iron with water. So aluminum and iron. So these are of one kind of reaction. So 2Al plus 3H2O gives Al2O3 plus 3H2. 3Fe plus 4H2O gives Fe3O4 plus 4H2. So in both the cases we get metal oxides, and hydrogen gas is common in both the cases. In all the cases we are getting hydrogen gas. So these are the reactions of metals with water. So either it will give metal hydroxide or it will give metal oxide, and in all the cases it will evolve uh, hydrogen gas will be evolved from this reaction as a product. So next we'll see reaction of metals with dilute acid. Reaction of metal with dilute acid. Now metal plus dilute acid gives salt plus hydrogen gas come out. So you have to remember Cu, Ag, Hg do not react with dilute acid. Now few examples where metal react with dilute acid. Examples: Fe plus 2HCl gives FeCl2 plus H2. Mg plus 2HCl gives MgCl2 plus H2. Zn plus 2HCl gives ZnCl2 plus H2, and 2Al plus 6HCl 2AlCl3 plus 3H2. So in all the cases, you see the salt is created whenever a metal reacts with dilute acid, and hydrogen gas is produced. Now we'll study about reaction of metals with solutions of other metal salts. Metal salts. So metal A plus salt solution B gives salt solution A plus metal B. Here, reactive metals can displace less reactive metals from their compound in the solution. So what happens here? More reactive metals displace less reactive metals from their compounds in solution form. For example, Fe plus CuSO4, FeSO4 plus Cu. Here, iron is more reactive than copper. Therefore, it displaces copper from copper sulfate solution and it produces iron sulfate, and copper is separated. Now we'll study about reactivity series. Reactivity series. So what is reactivity series? Reactivity series is a list of metals arranged in the order of their decreasing activities. The reactivity series is a list of metals arranged arranged in the order of their decreasing activities. Activities. So we can write the most reactive at the top. So most reactive most reactive So in the diagram we can see the reactivity series where the most reactive element is placed at the top and the arrow is in the decreasing order and least reactive element is at the bottom. So most reactive element is K, that is potassium, after that sodium, after that calcium, then magnesium, then aluminum, then zinc, then iron, then lead, then hydrogen, then copper, then mercury, then silver, and at last gold. So gold is one of the least reactive element. So this is all about reactivity series. Now we'll study about reaction of metals with nonmetals. Now, reactivity of elements is the tendency to attain the completely filled valence cell. So we'll study about the valence cell and all. So from so more reactive elements will have this tendency more. So it wants to complete its valence cell. Second is atoms of the metals losing electron from their valence shell uh, to form cations, and atoms of nonmetals gain electron in the valence shell to form anions. So we have to understand this concept. Valence shell and all. Okay. Now shell. We'll study in detail and for the chapters, but for now, the atomic number of sodium is 11. Fine. Then sodium can be arranged in 2, 8 and 1. So outermost cell. So if we draw sodium, so this is sodium nucleus, and the first cell of sodium, there are different orbits like cell, uh, imaginary cells outside nucleus. So in sodium we have 3 cells. In the first cell of sodium, 2 electrons are there. In the second cell of sodium, there are 8 electrons. So first cell contains these 2 electrons. Second cell contains 8 electrons. And the last cell, the outermost cell, which is also known as valence cell, contains 1 electron. To get stability, every element will try to get the atomic structure of its nearest inert gas. So sodium will try to get the stability by giving 1 electron, outermost electron, because it is difficult for sodium to take 7 electrons, but it is easier for sodium to give 1 electron. So this electron will be given up by sodium. So as soon as the electron is given up by the sodium, it forms a cation. So metals are always electron donors. So metals are cations. Now let us see the structure of chlorine. So chlorine's atomic number of chlorine is 17. So we can write A287. So if we draw chlorine atom, this is the nucleus, this is the first cell, this is the second cell, and this is the outermost cell, that is called valence cell. Now the first cell, chlorine contains 2 electrons. In the second cell, it contains 8 electrons. and in the third cell it contains 7 electrons. So it is always easier to get the stability of chlorine. Chlorine will try to get the stability of 288. So it is always easier for chlorine to get one electron. So chlorine takes one electron, therefore it has a minus sign. Anions. So it is a nonmetal, and nonmetals are always electron. Uh, they takes electron, so they are anions. Now we'll see how sodium and chlorine form sodium chloride. This is sodium, 281. This one electron, plus this is chlorine, with 287. Then what happens? Sodium give one electron to chlorine, and it gets the stability of 28 atomic, and chlorine gets 288. So since sodium gave one electron, therefore it forms cation, and chlorine takes one electron, therefore it forms anion. In this way sodium chloride is formed. This is the end of today's topic. Therefore, please subscribe, like and share our channel. Please click on the bell icon so that you can get automatic notification whenever a video is uploaded. Thank you very much for watching our videos. Keep in touch. Thank you.